In this video, we're going to introduce the notion of arc length via parametric equations. So say we have a curve like this, and let's call it capital C, and say that this is A, and say that this is B. And suppose further that this is a smooth curve, which basically means it has no sharp or jagged edges, which can be seen from the picture. Also, the curve doesn't really cross itself in any way. And let's say that the parametric equations for this curve are the following. Say we have x of t and y of t. So given a value of t, that will give us an ordered pair on the curve. So for example, if t is equal to 1, we would get x of 1, comma y of 1, and that would be some point on the curve. So as you let t vary, you get all of the points on the curve. So the arc length of this curve is basically the length. And the arc length is given by the following formula. So little s is equal to the definite integral from a to b of the square root of, and you basically take dx dt and you square it, and then you take dy dt and you square it, and then it's dt. So this is the formula that will give you the arc length. The derivation is relatively simple, but in this video I just want to focus on the formula and how to use it. So let's do a simple example just to get started right away. So let's say we have x equals cosine of t, y equals sine of t, and t varies between 0 and pi. So these parametric equations give you the unit circle. So basically we're just looking at the top half of the unit circle. We're going from 0 to pi, and it's just giving us this length here. So recall from basic math, the circumference of a circle is 2 pi r. So for the unit circle, r is equal to 1, so the circumference is 2 pi. But this is half of the unit circle, so the circumference is just pi rather. So our answer should be pi, because it's half of the unit circle. Let's verify that with calculus using the arc length formula. So let's find dx dt, which is, well, the derivative of cosine is negative sine. And then dy dt, that's the derivative of sine, so that's cosine. All right, now let's plug it into the formula. So little s is equal to the definite integral from 0 to pi, because that's what we're going from 0 to pi. It's usually given in the problem, the interval. And then we have the square root of, so dx dt squared would be negative sine t quantity squared plus, and then cosine t squared, so cosine t quantity squared, and then we have our dt. Okay, this is equal to the definite integral from 0 to pi. So we end up with sine squared plus cosine squared dt. And so basically sine squared plus cosine squared is 1, so it's really nice. So it works out beautifully. Square root of 1, so we just get 1. So going from 0 to pi, and we're integrating 1. It's wonderful. When you integrate 1, you just get t. And we're going from 0 to pi. And then you plug in the pi first, so you get pi. You subtract, you plug in 0, so you get 0. So you just get pi. So via calculus, the arc length is pi. Via basic math, the arc length is pi. Therefore, everything must be true. No, it is. This formula is valid, and it does work. So it's kind of cool to see that, you know, our calculus formulas agree with basic geometric formulas. So the main thing you should take from this video is the formula, right? It's pretty easy to remember. I hope this video has been beneficial. Take care.